Here at New Way, we are commissioning a new test stand for our air bearings and gas bearings and turbo equipment. So at this end, you can see there's 4 eddy current probes at 90 degrees from each other. 2 of them are looking directly at the shaft. 2 of them are looking at a target that is connected to the bearing cartridge. Now, between the bearing cartridge and this retainer, there's a squeeze film damper. So we're also able to see what the motion of the damper inside the retainer is and what the motion of the bearing inside both the retainer, inside both the bearing cartridge and the rotor. You can see here, for instance, we've got unbalanced weights. You can see how out of concentric that is. That's meant for spinning unbalanced between bearings and testing unbalanced loads at the first critical. So that would be like 2200 for the shaft that was of interest to us. But the idea is below 3000 RPMs, you can use these big unbalanced weights. So running at the natural frequency of the rotor, it will be spinning down in turbo gear. You can see this unbalanced weight spinning between 2 sets of bearings or pads. Then here you can see how it is rattling the whole table by looking at the water. See, the water will settle out. Set it down, it'll start. So we've got a real good shake going on here. Hey man, how much is your indicator shaking over there?
1,500 vibration on this side.
1,500 vibration. We've got this running at 2,400 RPM. Then at a balance weight of about 200 pounds, and it's shaking the shop. Okay, now we've been running this for 2.5 hours at 2,400 RPM. The unbalanced force is 400 pounds at that speed, and the waveform really looks about exactly like it did when it started. So it's just running the same now as it did when we started it after 2.5 hours.